Hey everyone, welcome back. In the last video, we spoke about post-order traversal using a stacked data structure. In this video, we'll talk about level order traversal using a queue data structure. Level order traversal is a breadth first search traversal, which means we visit all the nodes in the current level before we move on to the next level. The level order traversal for this tree here would look like this. We can say a root is at level 0. We have only one node and the output is 1. In level 1 we have nodes 2 and 3, so we have printed 2 and 3. In level 2 we have nodes 4 and 5, so we have 4 and 5 in the output. And in the last level, level 3, we have nodes 6, 7, 8 and 9. Now to do level order traversal, we shall use a queue data structure. A queue, as you know, is a first in first out data structure, which means the first element added to the queue is the first element to be removed. So we'll define a queue here. A queue in Java is an interface, so we shall use the linked list implementation of the queue. Initially, we shall add the root node to the queue. So queue.add of root, and it would look something like this. Now to do level order traversal, at each level we will first calculate the size of the queue. So here initially the size of the queue is equal to 1. Because we are at level 0, the size will be equal to 1. Now during each iteration, we remove the node at the front of the queue and process it. If the node has a left child, we'll add the left child to the queue. If the node has a right child, we'll add the right child to the queue. So we'll repeat this process until the queue is empty. So let's do that now. Now at level 0, we have only one node, so we'll remove that node and assign it to a node called current. We'll process this node, add it to the output. Current.left is not null, so we'll add current.left to the queue. Current.right is not null, so we'll add right to the queue. Now this ends the processing of level 0. Now for level 2, the size will be equal to 2, so we'll have 2 iterations. So we'll remove the node at the front of the queue or the head of the queue, which is 2. So current is assigned the reference to 2. We'll process this node, add it to the output. Current.left is not null, so we'll add current.left to the queue. Current.right is null, so we'll skip it. Now we'll remove the node at the front of the queue. So current is assigned the reference to 3. We shall process 3. We are still in the same level, so we'll append it to the previous output. Current.left, so 3 doesn't have a left child, so we'll skip it. 3 has a right child, so we'll add the right child of 3 to the queue. So this ends the processing of level 1. Now at level 2, we have 2 nodes. So size is equal to 2 and we'll have 2 iterations. First, we'll remove the node at the front of the queue, which is 4. So current is assigned the reference to 4. We shall process this node. Now add the left child 6 to the queue. Before that, I'll move this node 5 to the left so there is space. So current.left is not null, so we'll add node 6 to the queue. And current.right is not null, so we'll add 7 to the queue. Again, we'll remove the node at the front of the queue, which is 5. So current is assigned the reference to 5. We'll process node 5. Current.left is not null, so we'll add 8 to the queue. Current.right 9 is not null, so we'll add 9 to the queue. So this ends the processing of level 2. Now for the last level, we have 4 nodes. Queue size is equal to 4. So we'll have 4 iterations. Again, current is assigned the reference to the node at the front of the queue. So current will be equal to queue.remove. We'll process this node 6. We are in the new level, so we are adding it to a new list. 6 doesn't have a left child or a right child, so we can skip it and we can remove the next node from the queue. So current is assigned the reference to 7. We'll add 7 to the output. We'll process this node. 7 doesn't have a left or a right child, so we can skip it and we can remove the next node from the queue. So we'll process this node 8 now. 8 doesn't have a left child or a right child, so we can skip it. And current is assigned the reference to 9, so we'll process 9. And 9 doesn't have a left child or a right child, so we can skip it. And now queue is empty and the processing of all levels is complete. So with this understanding, let us try to code. Here the return type is a list of integer, so we'll create that. We'll name it output. We can define a queue of tree nodes based on the linked list implementation. We could do some error checking. So if root is equal to null, we can just return the empty list. Now initially we'll add the root node to the queue. Now let's begin the process of level order traversal. While queue is not empty, initially we have to calculate the size of the queue. So we'll have a variable called size will be equal to queue.size. We shall create lists for every level. So we'll have a list of integer, name it list. I'll use array list again. Now we have to iterate through the size of the queue. So for int I is equal to 0, I is less than size, I plus plus, we shall remove the node from the front of the queue. So tree node current will be equal to queue.remove. We shall process this node. So we'll add the node, the value of the node to the output. If this node has a left child, we'll add the left child to the queue. So if current.left is not equal to null, we'll add this node to the queue. So queue.add current.left. If the node has a right child, we'll add the right child to the queue. Now at the end of each iteration, we can add this list to the main list here, output. So put.add of list. And finally, we can return the output. I'll run this code. It's giving the expected output. I'll submit the solution. So it's working fine. Thank you very much for watching this video. If you liked it, please hit the like button and also do subscribe.